Hi. Welcome to the subject Fire Safety and Explosion. Today we are going to learn on Chapter 4, Dust Explosion. Dr. Sabrina and myself, Dr. Sidi Zubaidat, will teach on this topic. Enjoy learning. In this chapter we are focused on three main subtopics, which are dust explosion theory, concept, and dust explosion. Before we learn about the dust explosion, we need to know the definition of dust. Dust can be defined as a fine, tiny powdered, solid particle with size lesser than 1000 micrometer. Dusts of many materials used every day exist in the form of agricultural product, metal, woods, plastics, pharmaceuticals, and chemicals. For any of these materials, if finely divided and dispersed in air, can burn explosively. Dust pentagon. A dust explosion is different compared to a fire. Fire is caused when three elements, which are fuel, oxidant and ignition, are present. It is referred to a fire triangle. However, in dust explosion, there are 5 elements required, which are fuel, oxidant, ignition, dispersion and confinement. This is known as dust pentagon, as shown in the figure. This slide shows the 5 elements indicated in the dust pentagon that can initiate to the dust explosion. Dust or fuel. Airborne dust is actually a fuel source. When ignited it causes fire or combustion. When continued burning it leads to the explosion. If take out fuel, or dust from the dust explosion pentagon, it can eliminate from the fire and explosion. The dust size and concentration will affect the severity of the dust explosion. This will be discussed later. Oxidant. Air or pure oxygen is an oxidant that are required to the burning or combustion process. Ignition source. The ignition source causes the other elements to combust and creates a dust explosion. It can range from something as small as a static electricity spark or a lit cigarette, or a spark from metal parts scraping against each other. It also can be created when something just gets hot enough to ignite something nearby. Dispersion. Dispersion is process whereby the accumulated dust is spread out, mixed with the air, and creates a dust cloud. The accumulated dust needs to be cleaned up frequently to prevent it from having dispersion that can lead to the fire and explosion. Confinement. When the dust cloud is contained within a closed area, it causes issues with the confinement. The density of the dust cloud is constantly increasing, since the dust particles can remain suspended in confined air for days. The confinement will cause some pressure to increase when the dust cloud combusts, and cause the explosion to occur. How dust can be exploded. Dust explosion is initiated by the rapid combustion of a flammable particulate or dust that's suspended in the air. The ignition of suspensions of combustible dusts can occur from the initiation by flame or spark, propagation by gas explosion or blasting, and spontaneous combustion. During the combustion, heat will be released. The heat of combustion may result in the pressure development, flame propagation across the dust cloud and the evolution of heat and reaction product. The magnitude of the pressure rise can be described the explosion violence. The understanding of dust reactions. In order for the dust explosion to occur, all 5 elements in the dust pentagon must be present. Although mixtures of dust and air within the flammable range are capable of explosion, they will not explode unless they are ignited in some way. Once a source of ignition is presented to the flammable mixture, flame will propagate throughout the cloud. The heat produced by the combustion will cause a rapid increase in pressure at the wall of the dust cloud. The rapid heat generation and oxidation of the fine particulate creates a flame front. When the flame front propagates, an increase in pressure results due to the expansion of the internal gases caused by the heat generated is restricted by the vessel walls. This creates explosion, where the expanding pressure wave can cause damage to the vessel. Dust explosion can be categorized as either primary or secondary explosion. Primary dust explosions generally occur inside process vessels and units, while secondary dust explosions are caused by the dispersion of dust layers by an energetic disturbance. Primary dust explosion. The typical dust explosion event. As mentioned earlier, in order for an explosive dust cloud to be formed, the dust must be exposed to a process that suspends the particles in the air to the extent that the dust concentration drops into the explosive range. Most often such dispersion of dust to form explosive clouds takes place intentionally inside process equipment, as shown in the figure. After the explosion, the shock wave can damage and rupture the walls, allow the burning dust and gases from the explosion to be expelled into the surrounding area. The figure shows that the shock waves reflected by surfaces within the building cause accumulated dust to go into suspension. Look at the figure. The dust clouds thrown in the air by the shock waves. Now, the primary explosion breaks out of the equipment enclosure, creating a source of ignition. The secondary explosion ignited. The secondary explosion is propagated through the dust clouds. Secondary explosion bursts from the building. Secondary dust explosion. Collapsed building with remaining fires. The secondary explosion can cause severe damage to the surrounding plant buildings, and could be worse than the first explosion. Factor influencing a dust explosion: particle size, minimum explosive concentration or MPC, and minimum ignition energy or MIE. In this slide, we are going to discuss thoroughly the three factors influencing to the dust explosion: the effect of particle size. The smaller the dust particle, the more easily it is suspended. Small particles have large surface areas in relation to their mass, which can cause a greater explosion, and do not require a strong ignition source. In general, a decrease in particle size increases the likelihood of occurrence of a dust explosion, as well as its consequence severity. However, the MEC, MIE and MIT all decrease with decreasing of particle size. This is due to the surface area effects, where a smaller particle has a larger surface area and therefore enhance the reactivity. Maximum explosive concentration or MPC. It is referred to the minimum concentration of combustible dust and air required to propagate the flame. MPC is dependent on the size of the particle, the temperature of the ignition source, and the amount of oxygen in the air. Combustible dust cloud cannot be ignited when its concentration is lower than MbC. For most flammable dusts, the lowest concentration limit is 30 gram per cubic meter. The MbC value can be used as an explosion prevention method in areas where the explosive concentration of dust can be reliably controlled. Minimum ignition energy, or MIE. It is defined as the minimum amount of ignition energy released in a cloud of suspended dust, causing flame propagation, or the lowest electric energy that is capable of igniting the dust cloud at its optimum ignitable concentration. The dust-air mixture can be more easily ignited if the MIE value is lower. The ignition energies for the dust clouds generally require 1 to 10 mJ. Dust Deflagration Index, or KST. It measures the relative explosion severity compared to other dusts. During a dust explosion, more energy will be liberated if the severity value is higher. Rates of pressure rise are dependent on the volume in which the explosion occurs. In an attempt to volume normalize the maximum rate of pressure rise, a cubic relationship has been developed to define the parameter KST as the product of the maximum rate of pressure rise and the cube root of the volume in which the explosion occurs. The relationship is shown in equation below. The higher the KST value, the severe the explosion. Source of ignition. A dust explosion will occur only if the dust is dispersed in air or oxygen within the explosive range, and if only a suitable source of ignition is present at the same time. Ignition sources are varied and widely available in industry. The sources may come from flames and hot surfaces, spontaneous ignition, friction sparks, electrical plant and static electricity. Conclusion: combustible dust explosion hazard may present in a variety of industries. Knowledge about physics of dust is essential to determine the behavior of fire explosion. A dust explosion occurs when the dust cloud is formed in a confined or partially confined surrounding and ignited by a sufficient ignition source. Such explosion will initiate a primary explosion which can lead to secondary explosion. Knowing the minimum explosible dust concentration, minimum oxygen concentration, and minimum ignition energy are important to prevent open and smoldering dust fires. Thank you for your full attention.